Ellen, will you call it out to me? Or, isn't that what you said, 3? Oh, 9. Sorry. All right, guys. It was what? Square root or cube root? Like that? Okay. All right. So if I'm working through this one, there's multiple ways I can tackle this, right? I can simplify each radical before I start and then move from there to simplify, or I can just go ahead and get that radical out of the bottom. So there's not a right or a wrong way to do it, whichever way you would rather do that makes it easier on you. I think since these numbers are so small, I'll just go ahead and do this. Y'all okay with that? So this would be 3 root, I don't know why that keeps popping up. 3 root 40 over, this is just going to become 5, right? Over 40. Now that square root of 40, I can start to break up. I'm going to do 4 and 10. That's what you guys did. Square root of 4 is 2, and 3 times 2 is 6 root 10 over 40. Don't forget to simplify 2 outside of that radical. You simplify these two? Yeah. Divide them both by 2. That's exactly right. And what's left?
3 square root of 10 over 10.
Yeah. 10. Give me the.
All in one square root.
Like that. All right. So I would probably split this up before I start. Up top, 9 and 2. Right? So I would get 3 root 2 over. Can I take anything out of 30? I don't see anything I could take out of 30. So I'm going to go ahead and rationalize now. What you cancel? Well, you just put that there, so I don't want to cancel this. So I'm going to do 3 root 60, because I'm going to put these two together, right? Over, and now that's 30. Well, these I can both divide by 3. I know that, so I can do 60 over 10. But how about this one? Can I divide it by anything? 4 will go in, right? 4 and 15. You simplified it first. That's okay. Okay, if I take 60, I could do 4 and it goes in 115. So I get 4 root 15 over 10, and I can divide those both by 2. So you get 2 root 15 over 5. One of them has to be a perfect square, right? So 4 was my perfect square I divided it by, and I put, oh, you're right. 2. This is not there. Sorry. Stop me if I do something silly like that. Don't ever assume that. What else? Yeah. Can you call it out to me? I'm going to go ahead with the conjugate here. 4 minus 3 root 2. It really does get confusing with this kind when you got all these radicals in here, but we'll just trudge through it. 6 times 4. 6 times 3 root 2. 5 root 2 times 4. And then 5 root 2 times negative 3 root 2. 15. But what's square root 2 times square root 2? Square root of 4, which is 2. All right, on the bottom, 16 This one is the same, right? It's minus and positive, the exact same thing. So I'm going to leave that off. Will that confuse anybody if I leave that off? Those are your two that canceled in the middle. And then 3 root 2 times negative 3 root 2 would be negative 9 times 2, right? All right, let's clean it up. This is 30. So 24 and negative 30, negative 6. Negative 18 root 2 and 20 root 2, 2 root 2. And on the bottom, this is 18. 16 minus 18 is negative 2. Everything's divisible by what? 2, right? Now I'm probably going to divide everything by negative 2 since it's a negative 2 in the bottom. So I would get positive 3 minus, that's right, square root 2. Okay.
Wow.
14. Give it to me. So let's say I simplified this first. 4 and 2, yes? So on the bottom, so I got 4 minus root 2 up top. And on the bottom, 2 times, well, this is really 2. So I get 4 times the square root of 2, yes? Now what's the issue in my fraction? There's a square root in the bottom, so I need to get rid of it, right? Top and bottom only by the square root. So I end up with 4 root 2, because this has to distribute, minus 2 over, these two together make 2, so I'm over 8. Didn't distribute. And then I can divide everybody, good job, I can divide everything by 2. So I get 2 root 2 minus 1 over 4. Can you call it out to me? For 5 what? Like that? I'm probably, before I start, I'm going to simplify this. Because 2 goes into 4 how many times? 2. So I'm going to have square root of 5n over 2. I'm going to take that out just to make it a little bit easier. Remember, 2 goes into 4 how many times with how many left over? Now I multiply the top and the bottom by what? By just that root 15, that's right. It just makes me have a little bit more work on the back. I'm a little bit less work, excuse me, on the back end. 30, 60, 75. Over, this is going to give me 15, right? And 2 times 15 is 30. But 75 will break down, yes? What and what? 25 and 3, right? So you got 5 root 3n over. Can I simplify that 3 and 30? Not the 3 and 30, but the 5 and 30, yes, right? I can't simplify these two because this one's under a radical. I can only simplify with these. Does that make sense? I don't want y'all jumping to under the radical. So it's root 3n over 6n squared. I can't make that a 1 over 2 with the 3 and the 6. Don't jump under that radical. Yeah. What? Where?
You know how you said you can put them under the same radical? So
But
1/3 first?
No, because 3 and 5 aren't perfect squares. Oh, I see what you're saying. Yes, and you should come back to the same thing. Yes, you can do that. You can. I'm sorry, I wasn't fault. Yes, that was really smart, y'all. So yeah, they said this was the same thing as they kind of took this 1/2 out and said square root of 5n over 15n to the fourth. They put them together and then simplified them so they'd have a little less to work with at the beginning, and that's fine too. That's fine. That's fine. Yeah, it's fine. Anything else?
No, let's do 14. 14. 14.
Are y'all good? Or are you just making up numbers at this point?
No, I had started some, but now that you do it.
Now you got it. Okay. So you don't have to hanging over your head for the weekend. And Monday, I think we're going to pull everything and kind of review everything so far so we don't get so overwhelmed. Today is the 10th. I don't understand how it's already the 10th. It's making me sad. I'm not. It's going too fast. This is the time I want to slow down because it's Christmas season and I love it.
I love
I want it to go slow.
I want it to get I want it to get Christopher stuff.
But then I started driving and then I was slow down. So, yeah, once you get the now.
I don't want it to slow. I love Christmas.
So, let me tell y'all a funny story about this lesson. This was probably, I mean, it's not like real funny, so don't hope so, but years ago, whenever I was teaching this in an honors algebra 2 class, that's okay. There was an exchange student from Brazil in the class, and whenever I taught it, they were like leaps and bounds ahead of us at the school he was in. He's really smart. He was like, "Oh, can I show you how we did that in Brazil?" And I was like, "Well, sure." And so the method that I'm going to show you today, one of the methods I'm going to show you to do this, is what he taught, and it's so stupid and silly that it will just stick in your head and you'll never forget it. Because even my calculus kids, they'll say, "What am I supposed to do?" And I'll say, "Sunshine." They go, "Oh." So that's anyway. I'm leading up to it. I should have put. I know, you're just making me feel good. I appreciate you trying to make me feel good. Maybe you'll like it whenever I show you the method, because it really is so silly. All right. Tell me what a rational number is. You want to laugh? You want me to make you laugh? Keep going.
Integer.
Fraction. It can be written as a fraction. That's the key. So that's what we're kind of focusing on here. If it can be written as a fraction, meaning you can write it as a decimal, but it terminates or repeats itself, it can be written as a fraction. Things that are not rational, that are irrational, can you think of one common one that we use all the time? Pi. Pi is an irrational number. There's no fraction we can express it, but it goes on forever, no pattern. All right, so we're talking about fractions here when we talk about this. So we're talking about fractional exponents. Uh-oh. All right. Any root can be written as an exponent. And let me show you what I mean. Don't be scared. Well, the negative exponent flips it. This is going to be a fraction. So here's what happens. I'm going to just start with square root. Okay. Tell me what's that little imaginary number that sits outside the root? 2, right? What's the imaginary or implied exponent on the x? What's always there? 1, right? Here's what happens. To write it as an exponent, I keep the base the same, and I make a fraction out of this Oh, why does it keep doing that? Divided by this. That's right. So this will be x to the 1/2.
Oh.
It's funny you say in the house and out the house. Let me show you the method that JP years ago showed. I'm gonna have a green son. A son. There's my son. Woo, bless you. That's a sunshine. Thank you. I try really hard. Yeah. Okay, don't try to sell it now because it's an original work and I don't want to like. So, I'm always hesitant to tell this, but whenever I tell it, it's kind of embarrassing and it's so stupid. Well, but it's just, like, okay, so. What's in the radical? Oh, look, my face burning a little bit. So, yeah. Oh, it doesn't matter. I was just being silly. Yeah, that was just my artistic. This first one, look. This guy's really sad because he's in the shade. He can't get any sun. He's covered up. This guy's getting sunburnt out here in the sun because he's outside the shelter, right? So when you switch the form, you put him in the sun and you put him in the shade.
Sunshine!
So you sunshine it. So you just flip them. That's it. You flip them. But nobody ever remembers which one goes where. And so now I literally looked at calculus not long ago and went, sunshine it. And I went, oh yeah. So it's so stupid that you can't help but remember it because it's so stupid. Thank you. It wasn't me. It was JP from Brazil, like 10 years ago. Yeah. This is called radical form. This is called rational exponent form. And a lot of our problems we will be able to solve by changing forms from one to the other. So we're going to practice a little bit first in just changing forms, and then we'll practice with simplifying. Yes, sir. Ready? Ready, Freddies? You left one of those candies in here the other day, and one of my those little Smarties that you had dropped on the floor, remember? I was like, y'all don't even know where that came from. And y'all can pick it up off the floor and eat it. Somebody in my third block, I think it was Slade. Put that into radical form. Light work. What you got, Harris?
Wait.
Ooh. Sunshine it for real. For real, for real. All right, Harris. What's the root?
5 on outside.
That's exactly right. Boom.
Yes.
Now, I will tell you that this could also be written, it doesn't follow as much with the sunshine problem, but it could be written like that as well, and it's the same thing, but it doesn't matter. Let's do another one, and let's see if we might need to simplify this a little bit or anything. Let's say I have negative.
Ooh.
Change the form and simplify if you can.
Here, stop saying.
Maybe let's take the X off first. We'll do a next one next. Let's just do it. Okay, we'll keep the X on it, go. We're keeping the X, Malaya. We're keeping the X. We're keeping the X.
That's what you did.
If you need it. But this, remember, if you got an odd root, you don't need an I.
Oh,
All right, what's it look like when you change the form first?
Oh my God.
Not square root, cube root, right? Because it's the number on the bottom. Remember, he's in the shade now, so put him out in the sun. I guess I should have written it like this.
oh yeah, because I was about to say,
Because look, here's what I'm going to do.
Yeah, I simplified it. I did 2I.
Okay, why don't you need an I? It's cube root, right, right.
I thought you only put I.
All right, look. This squared, right, it's really for both of them. So yeah, it's -2, but then you have to square the -2 to get what? What's -2 squared? Well, but because what's the cube root of -8? -2, right? But then it's got this exponent of 2 on it that I also have to take into account. It doesn't matter. And watch what happens. If I do it this way and then I square it, I get 4. Yes? If I square it first, I would have the cube root of 8 squared is 64. What's the cube root of 64? 4 times 4 times 4 is 64, right? That stays under. That x squared has to stay under there. It doesn't simplify anything. Well, when I added these parentheses here and I'm squaring it, it's, yeah. It all comes back. That's a great point. One more. Oh. Turn up the heat just a little bit. Good, Harris? Dude, you're so good.
I was so tired of it.
Don't write it yet, Malaya. Now you can. Change the form and simplify. Change the form and simplify. Sunshine it and simplify it.
I can agree with you.
Because at this point, it looks like what you did last night and the night before, right? Yes, ma'am, maybe so. You don't have to, it's implied. Go ahead. Yep, then simplify. All right, let's go the other way with it. Change the form. Let's even make it harder. I just added a little form. Actually, you don't. Who's got it? Who thinks they got it? Yep. Now, I was going to say, before I start this one, because we're always in the process of simplifying stuff, right? I might simplify this before I start. In other words, this doesn't simplify, this doesn't simplify, but this one, 4 goes into 9 twice, and how many are left? And now I might change the form. So 2x3y to the 1/4. And so you'll ask me a question, do you multiply? And you absolutely do. Because I'm multiplying inside here, if I was adding or subtracting, this wouldn't work, right? But because I am multiplying in here, this can go to everything, and whenever it does, it multiplies to the exponents that are already there. So this would be y squared 2 1/4. X 3/4. I guess I kind of went backwards. I didn't really have to take that out because I could simplify it. I'd need to combine those, wouldn't I? That was my fault. Don't do that first.
Can you separate them? Okay, wait, can we start from like the beginning?
Yeah. If I do this, right, I could literally just do this. So I'd get 2 to the 1/4, x to the 3/4, y to the 9/4. Yes, because the root is 4. So if you sunshine it, right? No, you could. Did y'all separate them to start with? Is that what you did? Okay. So you went 4th root of 2, 4th root of x cubed, 4th root of y9.
Well, I did 2 and
Did you give them each their own exponent, though? Because they each get their own exponent.
4 root of y to the 4.
I got the same thing both ways. And I'd get the same thing here if I added 2 plus a 4th, if you put that on your calculator. I'd still get the same thing. Yes, they're all going to each have their own exponent. All right, if you flip over on the back, if you notice on the back, it's got some steps there. I ran this for you with the steps on here so you'd have them. It says to first rewrite in exponential form. Okay, and a lot of them are already in exponential form. And then you're going to use all those properties of exponents that you already know to simplify. What properties of exponents are we talking about? And this is what I want to spend just a minute talking about. That's exactly. If I'm multiplying with the same base, I add the exponents. Even if they're a fraction, x to the n and x to the m. Even if it's a fraction, right? If this was x to the 1/2 times x to the 2/3, I would say, what is 1/2 plus 2/3? And I don't know. Don't remember doing this, right? Yeah. Right? Multiplying same base, you add the exponents. Dividing with the same base, what do? Subtract, right? And I'm not going to sit here and go through every single little thing again because I'm going to assume you remember this from the last unit. If you have a power outside to a power, remember that means you do what? Multiply. We just did that. If you are multiplying inside parentheses, you can distribute to both. If you're dividing inside the parentheses, you can also distribute to both. What am I missing? 1, 2, 3, 4, 5. What happens if you have a negative exponent? It goes to the bottom. What if it starts out in the bottom negative? Then it ends up positive in the top. That's exactly right. So you're going to use those to work through the ones on the back. Tell me what you think so far. Me too.